Hello guys, welcome to my channel. In today's video I would like to talk about level measurement. Maybe you are driving your vehicle and you are wondering what instrument is used to measure the level of fuel in your tank. How does your car know that now you need to refuel? The answer to that question is level measurement. There are different types of level measurement that you will find in different applications. But in front of me, I've got three types of level measurement that I would like us to talk about. We're going to start from the right. On the right, we have an Anderson-Hauser level transmitter that is based on a principle of ultrasonic measurement. It's an ultrasonic level measurement. And we understand that ultrasonic has got something to do with sound. So that type of an instrument is using sound waves to measure level. But I will get into details how it does that. And then next to it in the middle, the silver one, that is a Vegabar. It's basically a pressure transmitter, but it can also be used to measure level. Let's say we have a vessel, and then we feel that vessel has got a known diameter and a known height. When we fill that vessel with a liquid, for an example, let's say we fill it up with water, that water will exert pressure or will cause pressure all around the vessel. So we can use a pressure transmitter to measure the level of a vessel in a way that the more water you put in a vessel, the more pressure is applied on that instrument. And then we can scale our instrument accordingly. And then through the scaling, we will know that a certain pressure is equivalent to a specific level. But that will require us to take into consideration the density of the medium and also the height of the vessel, the dimensions of the vessel. And then on the left, we've got a yellow transmitter. That one is a radar. It's a radar type of a transmitter. That one is based on light waves. I would say, just like we said, the ultrasonic is based on sound waves. This one is like a light wave, or it's like more like a radiation. That's why you have the word radar. We know in radiation we've got various types of radiation and a very wide spectrum of radiation, from gamma rays, we've got ultraviolets, we've got different types of radiation. So this level transmitter is based on that principle. So it will send a light wave, and then the time it takes for that light wave to travel and to hit an object is equivalent to the level, to the distance. So let's say if I'm sending a light wave, let me just make a short demonstration. Let's say I put this thing here, just a height above the table, and then this thing will send a light wave, and that light wave will hit the table and come back. The time it takes for that light wave to hit and come back is equivalent to the level. The far away I am, the longer it will take, if you understand. So it's related to the speed, to the time of light, to the speed of light, but I will just try to get a little bit into detail. But for now, it's just an overview. Okay, on the left, we've got our MSIN device communicator. For those who've been following my channel, I'm sure you know this instrument by now. It's basically used to calibrate instruments, to set up. It can communicate with a number of devices. As you can see now, I've connected it to my radar level transmitter, and then it's communicating. So it's a very useful instrument for people who work in instrumentation industry, automation industry. When you are in the field, you want to connect to the instrument and do some setups or troubleshooting. There's a lot of things you can do with it. But because the purpose of this video is just to explain how level is measured, I'm not gonna dwell much on the functionality or the features of the calibrator. Okay, so if you can see now, all my 3-level measurements that I've explained to you, I've only connected the one on the left. But like I said, I will explain in detail. With the ultrasonic, it's a sound wave that travels. Again, let me just try to zoom out a bit. So if I take this instrument and put it here and power it up and then install it, let's say on top of a vessel, it's gonna continuously send and receive sound waves. But then the time it takes for those sound waves to travel from the instrument to hitting the object, let's say the object may be my process medium, which is the water I'm trying to measure or whatever product I'm trying to measure. The time it takes depends on how far. So when my vessel is empty, the sound waves will travel from the top of the vessel all the way to the bottom and then come back. So it will take longer. But as the vessel fills up, let's say when it's halfway, the sound waves are going to travel from my instrument to the point where the medium is, the water is halfway, and travel back. So it will take shorter and closer. So we can set up those values and define at what range. Again, this is based on the size of the vessel and the type of their application. So the reason we've got different types of level transmitters is because one that will work for another process may not be suitable for another process. So obviously with the companies that manufactures this instrument, your Anderson Houses, Vegas, Yokogawa, Rosemount, etc., those companies, they will advise you that, okay, for this type of instrument is designed for this type of processes. So you will consult technical documentation to decide what level will work for your process. And then once you've decided, then you can set it up. Some are versatile, can be used for multiple processes. But I hope you're getting the point. Okay, I think I've already explained enough about the Vegabar. This one is also manufactured by Henderson Hauser. If you come closer, there are the specs. But the specs, they just explain the amount of pressure, minimum pressure, maximum pressure, and the type of current that you can apply to it, and the temperature, process environment that you can use that thing. If you can just look at both of them, the other one is like more like a plastic, or the other one is metal, the other one is a material that is not really metal. So if you are dealing with high temperatures, maybe this instrument might not be suitable, and then you might want to use this one, but you will consult the technical documentation. Okay, let's get quickly to the quick setup of the radar before we take too much time. Let me go through it quickly. All right, so let's continue. Now, if we focus on this radar level transmitter, you can ignore the temperature for now. This one, the manufacturer went a little bit far and he added a temperature sensor to the level transmitter. So that's just an extra feature, but we are interested in the level measurement. So this is a Vega instrument. Let's just go through the wiring a little bit. Most of these instruments will require a current source, which is in a form of a 4 to 20 milliamp. In this case, we are using our device communicator from MSN to power the instrument. But any milliamp source that you have, let's say you've got a Droog calibrator, or you've got a multimeter with a milliamp source, you can use it to power up the instrument. You just plug in the positive and the negative is labeled. And then we've got this display. This display is more like an operator panel. It's got a name for it. There's a name that Vega uses for it, but it's an operator panel that you can use to set up the instrument. Okay. The menu of this instrument, we've got escape, plus, then that one is like next, and then it's okay. If you press and hold okay, it takes you to the quick setup guide and then an extended setup. Let's not do the quick setup, let's do the extended setup. I'm just gonna come down Let's do it again. Okay, then next, and then we enter the extended setup. Under extended setup, if you look carefully, we've got setup, which is, that's where you set your minimum and maximum values, which is your zero and your span of the instrument. I'm trying to get it as close as possible. Okay, I think that's better. And then we've got display. Display is like you can decide if you want the language to be English or Dutch or French. You can also set up things like you want your screen to display one value or two values. Let's say, for example, this one is displaying both temperature and level. Those are the kind of things. Under diagnostics, you are getting errors. If an instrument is in a fault state, when you enter diagnostics, you're going to find errors there. And then you got additional adjustments where you can do things like damping, filtering. If you want to set up how long you want the instrument to update. Sometimes you want the instrument to update immediately, but sometimes you want the instrument not to be too noisy, meaning when you damp it a bit, it updates every 2 seconds or those kind of things. And then under info, you get the device model number, order code. That's information that you can use to contact the supplier. Maybe you want to speak to the supplier about the instrument. Actually, let me also show you the front side of the radar. The radar is like this. It's more like a light bulb. Inside the sensor, this is just a covering for the sensor, but the sensor is hidden behind there. And that's where the sensor generates the light waves and then receives them back. So it's sending and receiving, and then that's the principle it's using to measure your level. Okay, we can also access the same settings we are getting on the instrument on this side using our device communicator. As you can see, we've got setup, got display. Let's just enter quickly under setup. Okay, let's enter under setup quickly. So you can select the application. If are you applying this for water? Is it measuring solids? Is it measuring chemicals? Those kind of things. What the shape of your vessel, the height. That's where you define how long is your tank, so that the instrument can know the distance from the top side of the tank to the bottom side. That's basically your zero and your span. But you can always adjust those values. It does not have to match exactly the length or the height of your vessel, because maybe you want to set your 100% of the vessel to be not at the brim whereby the vessel is overflowing, but a little bit below. That's what you can do. Okay, you can go through, there's a lot of settings, like I talked about damping, we talked about current. The current output, you can reverse it 4 to 20 milliamps, or else you can do 20 milliamp to 40 amps. And then you can also set the fail state. If this instrument fails, do you want it to fail to a 0, which is less than 4 milliamp, or to a maximum, which is greater than 20 milliamps, or you want it to restore the last value? So when the time it failed, it was the instrument if the instrument was at 30, then it's gonna fail and display that last value. So these are very, very useful instruments, versatile, fancy instruments that we use in industry to measure level. But for more details, maybe you can consult a manual, or if you want me to mention a specific setting or explain a specific parameter that you are interested to know, you can leave a comment, and then I can maybe create a specific video that is focusing on one specific parameter and that. Okay, thank you so much for watching until this far. I hope you learned something, and if you enjoyed this video, if you like this video, please press like at the bottom, and also check my other videos under the automation and controls channel on YouTube. I will share the link below on the comments, and do subscribe for more videos of this type, and do share the video with your friends and other people who may benefit for it. Enjoy the rest of your day. Goodbye.